Welcome to Bala Sir's YouTube channel. Class 9th, Chapter 2, Work and Energy. This is your Part 2 video. Don't forget to subscribe our YouTube channel. You can see a red button below. Click that red button and like us. Today we'll be starting with Chapter 2, Work and Energy, Part 2. So today we'll learn about energy. What do you mean by energy? Energy means a capacity to do some work is called as energy. Let's say, for example, you want to pull a chair, you pull a car, or you want to pull a cupboard. What is required in your body? Energy is required to pull that in your body. So energy means the capacity. I write the definition here. If you want, you can note it down. The capacity of a body to perform work. This is called as energy. Now, how you express the energy? What is the unit for energy? The energy and work both are same. So the unit for the work energy is also same. So in SI unit, the unit for energy is joule, and in CGS unit, the unit for energy is erg. So you all learned that energy exists in various forms, like sound energy, light energy, chemical energy, magnetic energy, electromagnetic energy, nuclear energy, solar energy, mechanical energy. So these are the types of energy which you find in your daily life. Now today we'll learn about a special energy which we call it as mechanical energy. Mechanical energy. Now this mechanical energy is divided into two parts. One we call it as kinetic energy, and second is potential energy. Kinetic energy, the formula for kinetic energy is half mv square, and formula for potential energy is mgh. Now let's start first with the kinetic energy. Now what do you mean by kinetic energy? Let's start with some example. When I throw a ball, the ball moves from one place to another. That means there is a moving of the ball. If you play a carom board, a striker, when you strike the striker, it goes and hits the coin. The striker hits the coin in the carom board. You take a marble, you hit the other marble. That means in this example, what you understand, when a moving object strikes a stationary object, the stationary object moves. Like this is your striker, this is your coin, you hit the coin, but this coin is stationary, it is in its place, you hit it. That means this is getting a kinetic energy. Now in a cricket, you hit through the ball, you hit the stump, all the three stumps fall down, it shakes. That means kinetic energy. Thus the moving object, it has the same energy. So a part of all of which it shares with the stationary objects, thereby setting it in motion. When you play a football, you hit the football, but before hitting it, the football is in its own place, that we call it as stationary. You hit the football, that means you make the football in motion. So the energy which an object has because of its motion is called as kinetic energy. Let me tell you once again what do you mean by kinetic energy. I'll write the definition of kinetic energy. The energy which an object has because of its motion, we call it as kinetic energy. So the work done by a force to display a stationary object through a distance is the kinetic energy. So kinetic energy is equal to work done. Now what is the formula for work done? You have learned from the previous formula, previous lesson. Kinetic energy is equal to work done is force into displacement. So let us do some expression for kinetic energy using this force into displacement. This expression is very important for an exam. Expression for kinetic energy. Suppose any stationary objects, let's say mass m, it is in stationary, not moving. So if it is moving, it moves because of an applied force. So let u be its initial velocity, f be the force. This generates an acceleration a in an object, and after time t, the velocity of the object becomes equal to v. So the displacement during this time is s. So work done by the object w is equal to force into displacement. Now according to Newton's second law, do you remember that Newton's second law in the previous chapter? Force is equal to mass into acceleration. Now one more formula is there, that is S is equal to ut plus half at square. You remember this equation. Now we'll do one thing. From this equation, here the initial velocity, which is u, is 0. U is 0. Now put this u here. So S is equal to 0 into t plus half at square. It becomes S is equal to 0 into t is t. So S is equal to half a t square. Now here you got formula for F, you got formula for V. This is equation number 1, 2 and 3. Now we'll write this equation. W is equal to force into displacement. W is equal to force. Force is mass into acceleration. We'll write it as ma into displacement is half at square, which you got in equation number 3. So half here a t square. Now here force into displacement. So a t square. So here you can see 2a. So W is equal to m. So I'll write here first half m, a and t both have a square. So the whole square. So using the Newton's first equation of motion, Newton's first equation of motion, V is equal to u plus at. Now in this formula, as I suggest that u, the value for u is already 0 because initial velocity is 0. So we'll put 0 plus at. So V is equal to at. Now make it as equation number 4. Now in equation number 4, you put the value of at. Your at is V. So we'll put this at, the value of at, V here. So this will become W is equal to half m. In place of at, you put V here, so it becomes V square. Half mv square. Now as I said that kinetic energy is equal to work done. and this work done. Therefore, kinetic energy is equal to work done is half mv square. So in this way, you get the expression for kinetic energy. So the formula for kinetic energy is half mv square. The expression we already proved how you got the formula for kinetic energy. So let's have some problems. A stone having a mass of 250 gram. So here we'll write the data. Mass m is equal to 250 gram is falling from a height. How much kinetic energy does it have when velocity is 2 meter per second So here velocity is equal to 2 meter per second. Now this gram we want to convert it into kg. So that means 250 upon 1000 kg, you get it as 0.25 kg. So mass is 0.25 kg, velocity is 2 meter. How you got this velocity? It's given here. How you got mass? It's given here. So these are the data which we collect from the questions. Now we want to find what? How much kinetic energy? So kinetic energy is equal to half mv square. That is equal to half into m is 0.25 into v is 2 square. So let us calculate. Half into 0.25 into 2 into 2 because 2 square. 2 cancels. Now what is remaining? 0.25 into 2. So it comes to be 0.5. And what is the unit for kinetic energy? It is joule. So in this way, using this technique, you have to find the value for kinetic energy using these steps. So next, we'll start with potential energy. Let's start with potential energy. Now the definition for potential energy is the energy stored in an object because of its specific state or position is called potential energy. The energy stored in an object because of its specific state or position is called potential energy. Now let's say for an example, an arrow is released from the stretched bow. Now you know that the bow and arrow. So before using it, you have to stretch it here. So this is the potential energy. It is stretched. So stretched arrow is an potential energy. But when it is released, it is kinetic energy. Now water is stored in a dam. The stored water in the dam is kinetic energy. Water kept at a height flows through a pipe into the tap below. So that means water which is stored that flows into the pipe, that is potential energy. A compressed spring is released. It is due to potential energy. So if the object were not brought in those state, would they have been moved? So hold a chalk at a height of 5 centimeter from the floor. So this is potential energy. But when I release it, kinetic energy. Now stand up straight and then release the chalk. Is there a difference in the results in the two activities? So let us do the expression for potential energy. Expression for potential energy. Let's say you want to carry an object of mass m at an height of h above the earth's surface. So to carry the object, a force equal to mg is required. So work is equal to force into displacement. Work is equal to, here your force is mass mg, m into g, into your height is h. So potential energy is equal to work done. That is equal to mgh. Therefore, the formula for potential energy is equal to mgh. So displacement to height h cause energy equal to mgh to be stored in the objects. Now let us do some examples. 500 kg water is stored in an overhead tank of 10-meter high. Now here the data, always whenever you do the sums, you have to write the data first. So mass is given as 500 kg. Always mass should be in kg. In previous sum the mass was given in gram. So we converted it into kg. Here already mass is given as kg. Now height h is given as 10 meter. We want to find the potential energy, and G is fixed. It is 9.8 meter per second square. So potential energy is equal to mgh. Mass, what is the mass? 500 into G, 9.8 into H, 10. After calculating this, you get the value for potential energy as 49,000 joule. In this way, you have to calculate the value for potential energy. Transformation of energy. Energy can be converted from one form to another. So energy can be transformed also from one type to another types. Like let's say, these are the types of energy: electric energy, mechanical energy, heat energy, light energy, chemical energy, sound energy. Let's say when a bomb explodes, what type of energy you can see? You can see a light. So it is a light energy. You can hear the sound energy. You can feel the heat energy. So here, inside the bomb there was a chemical. So that chemical energy was converted into light energy, sound energy and heat energy. This electric energy can be converted into mechanical energy. For example, engine and fan. This mechanical energy can be converted into electric energy. Let's say example, generator. This electric energy can be converted into heat energy. As a heater, due to electric current, you can heat. Example, electric iron. Then let's talk about a light energy. Through the light energy can be converted into electric energy. Example, solar cell, photo electric cell. And this electric energy can be converted into light energy. Example, your electric bulb. Now chemical energy can be converted into electric energy, your battery, your cell. Electric energy also can be converted into chemical energy. Now sound energy can be converted into electric energy. Like when you talk through a mic, in a mic, the sound energy goes through the electric energy and you hear the sound. Electric energy can be converted into sound energy, that is the loudspeaker. So these are the transformation of energy. So energy can be converted from one form to another. So there is one law. The law is law of conservation of energy. Law of conservation of energy. Now tell me before this, can you destroy any energy? Can you create energy? So energy can neither be created nor be destroyed. We cannot create energy, we cannot destroy energy, but we can convert it from one form to another. Like previous example I said, energy transform from one form to another. Chemical energy is converted into sound energy. Sound energy is converted into electric energy. So we can convert this energy from one form to another. Thus the total amount of energy in the universe remains constant. This is the law of conservation of energy. Free fall. Now when I release an object from a height, it falls down. It gets pulled toward the earth. Why? Because of the gravitational force. So any object which is above the surface of the earth, it falls down due to gravitational force, and this we call it as free fall. So let us look at the free fall at kinetic energy and potential energy of an object which is moving for freely with a height of h. Now, let's say for an example, this is A, this is B, and this is C. From here till here, this is x. From here till here, this is h minus x. Because this AC is the height h. AC is height h, x. So this will be h minus x. So as shown in the figure, the point A is at the height h from the ground. Let the point B at a distance of x vertically below A. Let point C be on the ground directly below A and B. So let us calculate the energy of object A, B and C. First one, when the object is at stationary A, let's say when the object is stationary. What do you mean by stationary? It is in one place at A. Here initial velocity u is 0. Now kinetic energy is equal to what? Half mv square. Therefore kinetic energy is equal to, here when u is also already 0, so here in our kinetic energy V is equal to u square. So kinetic energy is equal to half into mass into 0. Kinetic energy here is 0. But what about potential energy? Your potential energy is mgh. No change in the mass, no change in the gravity, no change in the height. So what about total energy? Your total energy is kinetic energy plus potential energy. That is equal to 0 plus mgh. Here the total energy is equal to mgh. Let's say this is equation number 1. Now let's do the another one, equation number 2. Let the velocity of the object be vb. The velocity of the object be vb when it reaches at point B, having fallen through a distance of A. When any, now here object is a stationary A. Now we are making it fall. This is an object, it's stationary A. Now we are pulling the ball. It falls down to B. That is, the distance here is x. The velocity be v. Here the initial velocity is 0. Your height here taken as x. Acceleration is g. So here the formula v square is equal to u square plus 2as. Here your v is vb. vb square is equal to initial velocity is 0 plus 2 into your a is g and your s is x. So vb is equal to 2gx. Now kinetic energy is equal to half mvb square. That is equal to half m. Your vb is 2g and is 2gx the whole square. So here already it's given vb square. Your vb square is 2gx. So that means 2 and 2 cancel. So here the kinetic energy is how much? M, G and X. Now what about potential energy? That is height of the object when at B is h minus x. So potential energy is m g and your h minus x. So potential energy is equal to mgh minus mgx. So what about total energy? Your total energy is potential energy plus kinetic energy. Let me do this here. Have a look. I'll continue in this side. So total energy is equal to, what about potential energy? How much is potential energy? How much is kinetic energy? Okay, let me write first kinetic energy here, potential energy here. So kinetic energy is mgx. I'll write it as mgx plus your potential energy is mgh minus mgx. mgh minus mgx. mgx cancel. Your total energy is equal to mgh. In the previous one also you got the total energy as mgx, and in this also you got the total energy as mgx, which we call it as equation number 2. Next is let the velocity of the object. Now here we'll take the velocity as vc when it reaches at ground level c. In the first equation you saw it is a stationary object. Object is a stationary. In the second you saw it falls from A to B. Now in the third you see that the object moves from B to C. So here the velocity I made it as C. Again here also the initial velocity is 0, S is equal to H, A is equal to G. So V square is equal to U square plus 2AS. V square, what is V? Vc. I'll write it as Vc square. That is equal to, what is U? Your U is 0 plus 2. A is what? G. S is what? H. So Vc square, that is equal to 2GH. Kinetic energy is equal to half mvc square. That is equal to half m, your Vc is 2GH. Vc square is 2GH into 2GH. 2 and 2 cancel. So the kinetic energy is mgh. Now the height, when the ball reaches here, the height of the object from the ground at point C is 0. The height is 0. That means the potential energy is mgh. Here height is 0. That means potential energy is also 0. So your total energy is equal to kinetic energy plus potential energy. Kinetic energy is mgh. Here you got it. Potential energy is 0. So here total energy is equal to mgh. This is equation number 3. So from equation number 1, 2 and 3, what do you see common? You see that total energy is mgh. That means the total energy of the object is same at the 3 point A, B and C. Power. Power is equal to, the formula for power is work upon time. That means P is equal to W upon T. Now power is the rate, the time we call it as a rate. The rate at which the work is done, that the time at which, the time for which the work is done, we call this as a power. Now let's say for an example, can you climb can your parents, your father climb a stairs as fast as you can? No. Will you fill the overhead water tank? The overhead water tank, the tank which is above. Will you fill the overhead water tank with the help of a bucket or electric motor? You can fill it through electric motor, because with the help of a bucket it requires more power. Suppose your friend have to reach the top of a small hill. In that, the first friend went by car. First friend went by car. Second friend went by cycle. Third friend went walking. They want to go to the hill. So tell me, in all of them, choose the same path. Who will reach the first? The road is same. They have to go in this way. But one is using car, other using cycle, other is walking. The path is same. Who will reach the last? The person who is walking will reach the last. Why? Because in this example, the work done is same, but the time taken to perform the work is different for each person. Work done is same. What is the work done here? They're moving up, they're going, they're reaching the top. The work done is same, but the time taken is different because the car they goes first, cycle second, walking third. So the fast or slow rate of work done is expressed in terms of power. So power is the rate at which the work is done. Power is rate at which work is done. So let us start the read the unit. In SI unit, what is the unit of power in SI system? So in SI system, the unit of work is joule. You know that power is equal to work upon time. So unit of work is joule and unit of time is second. So that means it is joule per second, and this joule per second we call it as watt. So 1 watt 1 watt is equal to 1 joule upon 1 second. So in the industrial sectors, the unit is measured in the unit of power is measured in horsepower. In industries, the unit is measured in horsepower. Now what is horsepower? Horsepower means, as I said, 1 watt. So here horsepower means 1 horsepower, 1 HP is equal to 746 watt is 1 horsepower. Now this is used in industries. Now for commercial means the shops, schools, offices, there we use it in kilowatt hour. So here 1000 joule work is performed in 1 second is 1 kilowatt power. So 1 kilowatt hour, that is equal to 1 kilowatt into 1 hour. I split it. How much is 1 kilowatt? Kilo means 1000. So 1000 watt into 1 hour is 3600 second. That is equal to 361234 joule. So 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joule. Just see the zeros there. 1, 2, 3, 4, 5, 6. So you put the point here. It becomes 3.6 into, you went 6 step back, so it is 10 raised to 6 joule. So that means 1 kilowatt hour is 1 unit. Now this 1 unit is 3.6 into 10 raised to 6 joule. So electricity used for domestic purpose is measured in 1 unit. In the domestic purpose we use in 1 unit, and 1 unit is 1 kilowatt hour. This is the story of your power.